Let's see in this chapter location services in a wireless LAN design. Why do you need to learn this? Because this tool will help you optimize resources. It can become another troubleshooting tool. It can help you detect density. Remember that indoor location is needed because outdoor location is solved with the use of GPS. Some definition first. Position. Position is a relative distance given in meters or degrees. Location is geopositional coordinates relative or absolute to a point on Earth, so you can point something in a map. Accuracy is how a measure is close to a true value. It is given in meters. So for instance, we have good accuracy here and bad accuracy here. Precision is how measured values are close to each other. So in this case, I have good precision here and bad precision here. Notice that in this example, I have good precision but bad accuracy. There are a set of technologies that provide location for indoors, but they are seldom used. For instance, you can use ultra-wideband, which is a standard. It is hardly deployed at all. It provides good accuracy, but it is not supported by Cisco. You can use Bluetooth Low Energy or BLE. That is also a standard. It uses BLE objects and BLE beacons. It has several drawbacks. For instance, it depends on batteries. And some people can install your BLE objects. It provides good accuracy, and Cisco supports using BLE beacons on your access points. You can also use Wi-Fi 2016 extensions, which is not widely deployed, and it is supported to some degree by Cisco. So you have to rely on Wi-Fi infrastructure in order to provide location. Remember that some places within your building may be confusing to your location engine, for instance, staircase blocks, elevator shafts. In these cases, the receiving power can get lower, so your location engine can think that your user is moving away from your access point, whereas the user might be actually approaching it. So remember to map all these details on your mapping software. So let's remember how the traffic works with Wi-Fi. You can have broadcasts, or also known as probes. Your off devices will not be sending probes at all. Your devices that are associated can send probes to channels that they were previously associated with. But these probes are good in order to provide location, but these are not really frequent. If your device is approaching the edge of a cell, then this device will start sending probes to several channels. So this behavior is good in order to provide location, but it only happens when your device is approaching the edge of the cell. Your unassociated devices will also send probes to different channels, which is a good behavior in order to provide location, but it has the downside that these probes are usually sent with a different MAC address in order to provide privacy. This is known as locally administered MAC address. So in summary, using broadcast in order to provide location is good for all the devices that are on. You can also have unicast within your Wi-Fi, and for instance, the devices that are off will not be sending unicast. The devices that are not associated to any access point will not send any unicast at all. So your devices that are associated will be sending a lot of unicast, which is good for location, but it has a drawback. These frames only are sent within one channel. So the nearby access points that are working on a different channel will be not receiving these frames. So you will only have one access point that will be able to receive these frames. Unless you install access points in monitor mode, these access points will scan all channels and will be able to receive this unicast. So in summary, using unicast for location is excellent, but it has a drawback that only associated access points and access point in monitor mode will be able to receive them. So what are your options? You can use cell of origin on using only one access point. It will only provide you with presence. You can use trilateration, where you will be using 3 access points and sensing broadcast. This is good for associated devices or unassociated devices. It will be a bit slow in order to calculate the location. You can enable fast locate that will be enable the use of using unicast in order to provide location. This has the drawback that only associated devices can benefit from this, and you will provide faster location times. You can also use special access points that have a ring of mini antennas around them. These are known as angle of arrival access points. These work similar to radar, where you only need 2 access points in order to provide location. This is good for associated devices and non-associated devices, and the way this works is by sensing the different receiving powers at each of these mini antennas and calculating the device location that way. That is known as hyperlocation. So you need to have a location engine for all of this to work. This location engine will calculate the location of your devices. It will need maps. In order to provide maps to your location engine, you will need the Cisco Prime infrastructure, where you will be loading your maps. The information that the location engine will need is the client ID, the access point that gathers the information, the detector time, and the received signal strength indicator. So this information, for instance, for the access point that are using trilateration, is sent using the CAP-WAP tunnels to the wireless LAN controller. The wireless LAN controller will pack this information, process it, and then it will forward it to the location engine using the Network Mobility Service Protocol, or NMSP. For the access point that are using fast locate or angle of arrival, they will also send this information using CAP-WAP tunnels, but in this case, the wireless LAN controller will not process them and only forward them to the location engine. In order to have this in your enterprise, you will need the Mobility Service Engine, or MSE, which is the hardware, and the Cisco Mobile Experience, or CMX, which is the software. So don't confuse this. MSE is the hardware and CMX is the software. You can also have the MSE running as a virtual machine over Hyper-V or VMware, and CMX running above it. The more recent solution for Cisco is Cisco DNA Spaces that runs on the cloud. For all controllers, you will need a connector. For this, you can leverage the use of a CMX that has the version 10.5 or superior in order to have your wireless LAN controller send information to this connector, and then this connector will forward this information to Cisco DNA Spaces using the Network Mobility Service Protocol. If you have better version of your wireless LAN controllers, you can use a Cisco DNA Spaces connector, which runs as a virtual machine, and this Cisco DNA Spaces connector will forward the traffic that comes from this wireless LAN controller to the Cisco DNA Spaces using the Network Mobility Service Protocol. If you have really new version of your wireless LAN controller, they can be configured to send information directly to Cisco DNA Spaces, and for Meraki, your Cisco access points will send this information to Meraki Cloud, and the Meraki Cloud will send it to the Cisco DNA Spaces Cloud. That's it.